A generation ago, a balanced liberal arts education was measured by a student's ability to read and write and their knowledge of the humanities and social and natural sciences. In my generation, the focus shifted on being able to use PowerPoint and Excel, and being able to communicate. In the next generation, students are required to have a data fluency, an ability to code, and to be able to communicate ideas. Everyone will learn to program, and you should too. Here's why. Computers are everywhere, but they have been for over a generation. So what's different? Well, today, data are everywhere. Every profession, hobby, and everything in between is being influenced by data. Do you like reading? Well, Goodreads or Amazon will have recommender systems to tell you what's next. Same for Netflix or Spotify. Literature? Natural language processing is pulling sentiment analysis out of text and doing things like determining if Shakespeare really wrote Shakespeare. Selling something? Well, customer data has always been gold, but now A/B tests are determining which is the more clickable ad and then shifting your marketing strategy midstream. Maybe you're into fitness or running. Now you can track workouts and heart rate variability and determining what you need to do to achieve peak performance. Maybe you're into art. Style GANs or generative art are being used to create it, and now NFTs are being used to sell it. And so I'm not making the case here that everybody needs to be a computer scientist, but everybody needs to learn to program. Now, what exactly do I mean by program? The distinction between coding and programming maybe is a little bit nuanced and niche, but I think it's an important one. Coding is writing instructions for a computer to understand. Programming is telling that computer to do things, the things that we want to do. So let's make a simple analogy. Coding is like writing a sentence. Programming is like writing a book. See, programming is tied to the output. If you're an author, no one's going to ask you, what language do you write your book in? Similarly, if you're writing a computer program, no one's going to ask, oh, what language did you write your code in? I made the case several times before that whatever programming language you choose to learn first to do coding, I've argued that it doesn't matter. It doesn't matter because you want a programming language that is going to allow you to do the thing that you want to do, to make the output that you want to make. And see, unlike an author writing a book, computers have several different outputs. Computers can make video games, they can analyze data, they can make software or operating systems. See, the output is going to be varied and diverse, just like the languages you are using to generate those outputs will also be varied and diverse. Now, I've often said that the programming language you choose to learn first doesn't matter, but this is only mostly true. There are a couple of instances where the programming language might matter. Now, first, if you're collaborating with a team and the team uses one coding language in order to do their computational work, it's going to be important for you to be able to speak the same language in order to leverage that team. Just like if you spoke English and everybody on the team spoke Spanish, it would make more sense for you to learn to speak Spanish so that you can communicate with the rest of the team. Second, oftentimes you want to leverage open source software. If that open source software is written in a certain language, you need to be able to speak the same language in order to leverage all of the work that these open source software developers have put into. And third, sometimes there are some technical requirements or limitations that you will need a certain language for. Like I said before, if you are building an operating system, that'll be very different than a game. Games are going to require some frameworks, whereas operating systems and compiling kernels will require other frameworks. But the point that I'm trying to make here is that coding is not the important thing. Programming and thinking like a computer programmer is going to be what's important. Now, you might say, well, what about no code? Where does no code fit into all of this? Well, no code is also a type of code. It's just that instead of using words and text to write the code, you're using pictures and blocks for operations. But fundamentally, no code is also computer programming. Now, you don't need to be a computer scientist in order to learn to program. Just like you don't need to be a doctor in order to keep yourself healthy, or you don't need to be an architect in order to fix up your house. You need to be able to understand some of the basics and some of the fundamentals of computer programming. Now, this is not some future possible universe. This is here today. Like any learning project, You need motivation to start. So go ahead and find a question or a problem that you want to try to solve. This is going to be the motivation for you to dive into programming. Then little by little, your knowledge will compound and you will go deeper and deeper and be learning more and more. Fortunately, anyone with internet access can mine the world's knowledge and learn to program. The tools and resources to learn this are better than they've ever been before, in large part due to open source software developers. So go ahead and hug your open source software developer today. But seriously, Steve Jobs said, everyone in this country should learn how to program because it teaches you how to think. Beyond the tangible benefits of programming, learning to program has several second-order effects. It teaches you how to think. It teaches you how to solve problems. And we all know today, there are more problems facing our society than ever before. And so we certainly need the next generation of people equipped to solve these problems. Learning to program will empower the next generation of entrepreneurs, of policymakers, of educators, and just perhaps of you too.